Hello, students. Today, we have conditions and loops on our agenda. We are already a bit familiar with conditions. And in this direction, we will take a second round. Those who want to refresh their memory, please review the lesson on Boolean values. That's where all the basics are. So, conditional statements are one of the most important concepts in programming. A conditional statement is a fork. If something is true, do this, otherwise, do that. Example, if you complete your homework, you can have ice cream, but if the homework is not ready, no ice cream for you. And a loop is an instruction. As long as something is true, keep doing it. Example, as long as you are thirsty, continue drinking water. Conditional statements and loops are the foundation of any program. They are called control structures because they allow you to decide which parts of the code to execute and when, as well as how often to do it, based on the conditions you set. There are two types of conditional statements in nature, if and if-else. The if operator executes a piece of code if some condition is true. This is all. Such a fork is called incomplete because it lacks a second half. For example, if you behaved well, you get a candy. But the if-else operator has the ability to branch the program into two parts. If the condition evaluates to true, one block of code is executed, and if the condition evaluates to false, another block is executed. For instance, if you behaved well, you get a candy, otherwise, you won't be allowed to go out. Here's a practical example of using the if operator. Let's say you've set up control, and during a walk, the character is suddenly struck by death. You can still control the character regardless of their state. And that's where the conditional if construction comes in handy. The character can move only if they are alive. And we can save this state in a variable named isAlive. By default, the value will be true, which means the character is alive. And if the character dies, we change this value to false. Now, in the control section, we connect a block, is true, to all the keys and check the value of the alive variable. Now, the movement key doesn't immediately move the character, but first initiates a check, and the control signal will only pass further if the condition returns true. In other words, we can now only control the character if they are alive. Let's move on. Now an example with full branching. We have a door, and it can only be opened with a key. And here we need two possible developments of events. If we try to open the door without a key, then the animation of a closed door starts. And if we have a key, then the door opening animation starts. The scheme is just as simple as the previous one. Just on the block with the condition, there are now two outputs. Until we find the key, the checked variable stores the value false. And the program will launch the false channel. As soon as we pick up the key, the variable changes its value to true, and the next attempt to open the door will initiate the true output. One check, two different options. Nothing complicated. I'll remind you that conditions can be combined. I won't repeat myself. If you've forgotten what it looks like, go back to the lesson on Boolean values. There's an excellent example of a composite condition. But for now, let's move on to loops. As we now know, conditional constructions allow us to run a code fragment if the condition evaluates to true. Loops, on the other hand, allow us to execute a code fragment repeatedly, as long as a certain condition evaluates to true. Examples from life: as long as there is food on the plate, continue to eat. Or, as long as there is dirt on your face, continue to wash it. Let's see what this looks like in the logic editor. I will create a new logical branch and attach it to the sphere. Suppose we need to output the string hello world 10 times in a row to the console. If there were no loops in this world, we would have to mold something similar. We would have duplicated the same code segment many times, and it would take up a lot of space. Yes, the program works, but it looks terrible. Making changes to such code is very difficult. And searching for errors can turn your life into hell. Therefore, such a construction should be replaced with a more elegant one. The simplest type of loop is the loop with a counter. In the block, we specify the number of repetitions. And to the loop output, we connect the block of code that needs to be executed. Now the code looks much clearer. And in the console, we can see the same result. But that's not all. There is an index output on the block. From it, we can get an integer value with the number of repetitions. If you connect this channel to the console output, you will get 10 values. From 0 to 9. And this channel greatly expands our possibilities for using loops. For example, we can number the output in the console. For this, you can use string concatenation. Now each output will have an ordinal number added. Or, we can add a condition that will check the iteration number, and when it equals 5, we will output in the console not the standard phrase hello world, but something else. Now variety has appeared in the console. Or, we can use a condition to break the loop. Just add a loop break block. And now our loop consists not of 10 iterations, but only of 6. Another common type of loop is the while true loop. It contains a condition check. And this loop will work as long as the condition gives true. As soon as the false value comes to this channel, the loop will be interrupted. Care must be taken with this beast. Because if you do not create an exit condition, this loop will work indefinitely, and your game will hang. If this happens, you need to call the task manager. For example, by pressing Ctrl-Shift-Escape. Find the game window in the list, and forcibly end the task. This block has two downsides. It requires careful attention to the condition for breaking the loop, and this block does not have a channel with an iteration index. But this block has the ability to repeat code exactly until the needed event happens. For example, we need to output to the console all the results of raising the number to a power, but not exceeding 1000. In this case, it would be difficult to use a loop with a counter. Because we don't know how many repetitions we will need. It's much easier to do this using a while true loop. Let's start the program with the spacebar. We'll create 3 variables. In the variable current value, we will store the current value of the number to raise to the power. By default, we set the value to 2. The second variable, max value, will be our threshold at which we need to interrupt the loop. 1000. And the third variable, named loop continues, will store the Boolean value true. Thanks to it, the loop will continue its work. We'll connect the getter of this variable to the loop condition. Now we just need to write the body of the loop. We take the variable current value, multiply it by 2, override the value, and output the result to the console. If we run the program now, we will get an infinite loop because the variable loop continues will always be in the value of true. All that remains to be done is to change the value of this variable to false at the right moment. Inside the loop, Right after the output to the console, let's build a check using a gate block. If the current value becomes greater than the maximum, we will change the value of the loop continuous variable to false. And in the next iteration, the loop will be interrupted. Excellent! The scheme works. In the console, we see the result of raising the number to a power. But there is a little problem. Our task was to output values not exceeding 1000. And in the console, the last line is 1024. That is 2 to the 10th power. So we need to interrupt the loop one iteration earlier. And I leave this task to you for an independent solution. Whoever can interrupt the loop so that the values output to the console do not exceed 1000 will earn universal respect and a golden ring in the nose. You cannot change the max value variable. You need to reformulate the condition within the loop. Have fun! In the next lesson, we will apply the knowledge gained on a more hardcore example. Bye for now.